In this video, we'll walk through the basic setup and operation of the DMM DYN1 integrated servo motor and drive unit. The DYN1 combines the servo motor and drive into one compact package, which helps reduce wiring, simplify installation, and save space inside your control cabinet or overall setup. Instead of mounting a separate servo drive and running motor power and encoder cables between the drive and motor, the drive electronics are built directly into the motor unit. This video will be intended as a practical setup demonstration for users configuring the DYN1 on their own machine or test bench. To ensure the power supply voltage and current capacity match the requirements of our DYN1, we will be using our 48-volt DC power supply. Depending on our specific configuration, we are able to manually adjust our DC voltage as needed. For this demonstration, we will set our power supply to output at its maximum voltage range. The DYN1 is versatile in this sense, allowing an input of 24 to 75 DC voltage to the unit. We will first connect power to our unit using DMM's DYN1 DC power cable. This plugs into the JP1 connector on top of the DYN1. Ensure the cable is tightened and secured to prevent it from loosening during operation. For communication to our host machine, we will connect our USB tuning cable through the JP2 connector. This allows the DMM drive software to detect the unit, read parameters, change configuration settings, and perform drive tuning. Likewise, ensure that the cable is tightened and secured to prevent it from loosening during operation. Depending on your setup, you may also connect control signals such as enable, alarm reset, step and direction, pulse command, or other I/O signals. For this demonstration video, we'll focus mainly on initial setup and basic motor movement. After powering the DYN1, the motor should be stationary and the unit should be ready for communication. Open the DMM drive software on your computer. We will be using the software to configure, tune, monitor, and test the DYN1. First, select the correct communication port and connect to the drive. Once the software connects successfully, you should be able to read the drive information and confirm that the correct model is detected. Before making changes, it is good practice to read the existing drive parameters. This allows you to view the original configuration in case you need to return to the starting point later. Make sure the motor is securely mounted or placed in a safe test setup before enabling motion. Next, we'll tune the DYN1 using the DMM drive software. The goal is to achieve smooth, stable, and accurate motion without vibration, overshoot, or excessive noise. We must also ensure that our gear number is set to 16384 for the encoder's maximum resolution. The DYN1 is equipped with a 16-bit absolute magnetic encoder, resulting in precise positioning and smooth, reliable performance. With that being said, we will be selecting RS-232 for our serial communication. We can test motor movement live using the test parameters below. Running the motor at a constant speed allows us to observe its characteristics at the selected gain values. Here we can also test and reverse the direction of the motor. Applying a sinusoidal motion will also help us determine new parameters to then save onto the drive. If the motor response feels too soft or slow, the gain may need to be increased. If the motor vibrates, oscillates, or makes excessive noise, the gain may be too high and should be reduced. If you want to learn more about tuning the drive to your specific application, you can view our DMM Drive user manual found in the Resource Center of the DMM website. That completes the basic setup and motion demonstration for the DMM DYN1 integrated motor and drive unit. For final installation, always refer to the official DYN1 documentation for wiring configuration and setup procedures, as well as detailed electrical ratings and safety instructions. Thank you for watching.